need to collect user information interactively, but tired of building complex forms or handling messy input validation. We'll create a FastMCP tool that pauses execution to prompt users for structured data, like name and age, then handles their response, whether they accept, decline, or cancel. You'll see how the ctx.elicit method turns a simple data class into an interactive prompt, with built-in validation and clean response handling.
From FastMCP, import FastMCP. Context. From data classes, import dataclass. MCP equals FastMCP. Elicitation server. At dataclass. Class user info. Name, str. Age, int. At MCP, tool. Async def collect user info ctx, context, str. Collect user information through interactive prompts. Result equals await ctx, elicit. Message equals please provide your information. Response type equals user info. If result action equals accept. User equals result data. Return f hello username, you are usering, years old. Elif result action equals decline. Return information not provided. Else hash cancel. Return operation canceled.
This demonstrates interactive user elicitation, a pattern for dynamically collecting structured input during tool execution. Unlike traditional APIs that require all parameters up front, elicitation enables tools to pause mid-operation and request missing data, clarification, or approval from users. The distinctive aspect is its bidirectional nature, blending programmatic control with human-in-the-loop decision-making. The pattern works by establishing a conversation contract between tool and user. When execution reaches an elicitation point, the framework suspends the tool, sends a structured request to the client, and awaits a typed response before resuming. This creates a clean separation between the tool's core logic and its interactive requirements, with the context object managing the elicitation lifecycle. This approach solves the problem of incomplete or ambiguous inputs in automated workflows. It's particularly valuable for complex operations where requirements emerge dynamically or where human judgment is needed. The trade-off is added latency from user interaction, but the benefit is more robust, user-aligned tool behavior that can adapt to real-world variability. Let's break it down.
From FastMCP, import FastMCP. Context. From data classes, import dataclass.
Imports FastMCP for creating AI-callable tools and context for tool execution state. The data class decorator simplifies structured data handling, eliminating boilerplate for the user info model.
MCP equals FastMCP. Elicitation server.
This initializes the FastMCP server instance named Elicitation server. This is your central controller for all AI-callable tools, handling registration, execution, and response routing.
At data class. Class user info. Name, str. Age, int.
This defines a data class for structured user information. The @data class decorator auto-generates boilerplate like init, ensuring clean attribute access while eliminating manual constructor code. FastMCP uses this schema to validate and parse the elicited response into a strongly typed user info object.
At MCP, tool. Async def collect user info ctx, context, str. Collect user information through interactive prompts. Result equals await ctx, elicit. Message equals please provide your information. Response type equals user info.
This defines an AI-callable tool that collects structured user data. The ctx.elicit method triggers an interactive prompt, using the userinfo data class to enforce type safety on the response. All FastMCP tools require this context parameter for logging and progress reporting.
If result action equals accept, user equals result data.
This checks if the user accepted the information collection prompt. On acceptance, it extracts the validated userinfo data from result data, which FastMCP automatically deserializes from the response type class. This pattern ensures type-safe data handling between interactive prompts and business logic. FastMCP elicitation pattern. This code demonstrates the core interaction loop, where servers request structured data through elicitation, and clients respond with typed results wrapped in action states. The response type data class must exactly match the server's expected schema, or FastMCP will reject the response silently. Always handle all three action cases: accept, decline, and cancel, to prevent undefined behavior in production.
The schema that disappears into the data class still governs every possible answer.